Hello everyone, welcome back to the channel. In my previous tutorial, I have already explained how to perform cloud masking, apply scaling factor and calculate NDVI using Landsat 8 collection to level 2 imagery in Google Earth Engine. Since we have already covered those topics in detail, I won't repeat them in this video. So today we are going to build on that knowledge and calculate another very important drought related index called the Vegetation Condition Index, or we can say it as VCI. So by the end of this tutorial, you will learn what the Vegetation Condition Index is, like why is it important, how VCI is calculated from NDVI, and many others. And finally, we will export the VCI map as a GeoTIFF. So, so first of all, the question is, what is Vegetation Condition Index? Before writing any code, let's first understand what VCI actually measures. So this is VCI, the Vegetation Condition Index. It's a vegetation health indicator developed from normalized reference vegetation index. So unlike NDVI, which only shows the greenness of the vegetation at particular time, VCI compares the current vegetation condition with its historical minimum and maximum values. So this makes VCI especially useful for identifying vegetation stress caused by the droughts. So VCI is widely used in drought monitoring, agriculture assessment, crop health analysis, and many others like forest management and climate change studies and many others because it is involved NDVI. So its values ranges from 0 to 100, like generally from 0 to 20 indicates severe vegetation stress or extreme drought. Then we have 20 to 40 indicate moderate drought indicators, and if we jump from 80 to 100, that represent very healthy vegetation with little or no stress. So the VCI formula is very simple. It's NDVI minus NDVI minimum, then NDVI minus NDVI minimum, and then we will multiply it with 100. So here is the NDVI involved in VCI that I have already explained. It selected the NDVI image, then subtracted, divided, and multiplied. Let's explain it line by line. So the first is the cloud masking. As mentioned earlier, this function has already been explained in the detail in previous tutorials. So what its purpose is, it's the QA pixel we have selected. It's to remove clouds and cloud shadows using this band. Then we have QA red set that remove radiometrically saturated pixels using this band. And then we have applied the official scaling factor to convert the optical bands into surface reflectance values. So this prepare clean Landsat imagery for the analysis. Then we have Landsat imagery loaded, and then we use filter bounds to filter it to just our study area, like it's limit the images to our region of interest. And then we selected all the Landsat images acquired between January 2021 and December 2022. So instead of analyzing a single image, we are working with the 2 years of observation. So this provide a better representation of vegetation condition over time. And finally, applies our cloud masking function. Here is applies our cloud masking function to every image in the collection. Then we have calculated NDVI. Inside this function, here is the function. We have used image dot normalized difference. So remember that band 5 is the near infrared and band 4 is the red band. Earth Engine calculate the normalized difference automatically using the standard NDVI formula, and then rename the output band as a NDVI over here. You can change it if you wanna change it. So at this stage, every image in the collection now contain an additional NDVI band. So we have applied cloud masking by using different bands. Then we have uploaded our Landsat imagery. We have bound it to our region of interest. We have uh, given it a date, a specific date that we're gonna work on, and we applied the function of a cloud masking to every image, and then we have calculated NDVI so far. So now let's move on to calculate VCI. Okay, so now we need to determine the minimum NDVI value across the entire image collection. Uh, we do that with a variable that is minimum NDVI, and Landsat dot select NDVI dot reduce EE dot reducer dot minimum. So the reducer dot minimum function examines every image in the collection and determine the lowest NDVI value for each pixel location. And this produces a new image representing the historical minimum NDVI. Similarly, we calculate the maximum NDVI, that is historical, or created a variable max NDVI, Landsat dot select NDVI dot reduce E reduce dot maximum. So here again, reducer dot maximum identifies the highest NDVI values observed for each pixel during the study period. So now we have two important references images, the minimum NDVI and the maximum NDVI. So these will be used to calculate the vegetation condition index. Now comes the most important part of that is VCI. So we loop the every Landsat image again. We have created a variable VCI collection is equals to Landsat dot map function, and inside we have image. Inside the function we implement the VCI equation exactly as defined earlier. So first we have image and then dot select NDVI. It will select the NDVI bands from the current image. Next we have dot subtract minimum NDVI. It will subtract the historical minimum NDVI. Then we have dot divide maximum NDVI dot subtract minimum NDVI. That will divide the difference between the historical maximum and the minimum NDVI. And finally, we will multiply it with 100 and rename it as a VCI. So this was the formula to calculate the VCI using minimum and maximum NDVI. So we rename this a new band as a VCI and add it back to the images. So this process is repeated automatically for every Landsat image in the collection. So we have another variable VCI image. So we have created a median over here. So the median function combines all VCI image into one composite image by selecting the median value of each pixel. And this reduces the influence of outliers and produces a stable representation of vegetation condition. Finally, the image is clipped to the study area, that is region of interest. And then we have visualization parameters, like we have defined the minimum value, we have maximum value, and we have also defined a palette that is from brown to green, and then VCI. So the palette here, brown represents with a poor vegetation condition, yellow indicate moderate vegetation condition, and green represent healthy vegetation with little or no stress. So you can see green over here. We will explore it in a detail. So once you will run the script, the VCI map will appear on the Google Earth Engine map window. It's over here. So this is how our VCI values looks like. Let's inspect it and see the values of the greenish and the yellowish or maybe brownish sides. So we have first value that is representing 77, and then let's do it in the brown. We have 21 at the brown, and then let's have on the yellow we have 59. So the values that are largest are in the greenish sides, so it's representing a healthy vegetation condition over the greenish areas. So finally we have export function. So we will export the results over here. We will use export dot image dot to drive. So here the image specifies the VCI raster. The description uh, gives the export task a name. Then we have scale, that is 30, maintain the Landsat 30 meter spatial resolution. We have then region, define the export boundary. Then we have file name, that is GeoTIFF, saves the output as a GeoTIFF file. Then we have max pixels uh, is increased to allow exporting large study areas. After the export is complete, you will find the GeoTIFF file in your drive folder, uh, ready to use in ArcGIS Pro, QGIS, or any other software you wanna use. So that's all for today's tutorial. If you found this tutorial helpful, please like the video, subscribe to the channel, and turn on the notification bell so you don't miss the upcoming Google Earth Engine tutorials. Thank you for watching. I'll see you in the next video. Bye.